In this video, I want to discuss comparison to test whether something diverges or converges. And what that means is we want to compare different series together and to see whether a series that we're not familiar with it converges or diverges. And if that sounds complicated, you will see what I mean in 1 second. So let's say we're going to start with an example. Let's say we have the series ace of n is equal to 1 over 4 to the n plus n. And we want to see if the infinite sum, so I'll just say the infinite sum of ace of n, I'll just write it like this, diverges or converges. And the way we're going to do this is we're going to compare this to some series that we are familiar with. Now, maybe pause the video here, think about maybe what we can compare this to, and then keep watching the video to find the solution. Okay, so I'm assuming you've paused the video. So the series we want to compare this to is I'll give it a name. I'll say v of n is equal to 1 over 4 to the n. And the reason why we want to compare it to this is because we actually know a very specific formula for the infinite sum of this series right here. And another reason why we're comparing it is because we know, this is actually very important right here, we know that 1 over 4 to the n plus n is less than 1 over 4 to the n. And think about this for a second. It means any term in this sequence series is less than this sequence or series. So if I plug in 1 for n, I get 1 over 4 to the 1 plus 1. And this is less than 1 over 4 to the 1. 1 over 4 to the 1 is just 1 over 4. 1 over 4 to the 1 plus 1 is 1 over 5. We know that 1 over 5 is less than 1 over 4. And because every corresponding term in ace of n is less than every corresponding term in vis of n, that means the infinite sum of ace of n, so the infinite sum of ace of n, is also less than the infinite sum of vis of n. So if we find a value for this infinite sum of vis of n, and we find a value for it, which means it converges, then this, which is less than this, has to converge as well. And again, I really encourage you to think about that and understand why that is. Again, I'm going to repeat that one more time. If we have an infinite sum that we know, and let's say, I don't know, the value of this, let's just say is 10. And we know that this has to be less than 10. Well, that means, a value less than 10 is definitely not infinity. So for that reason, it converges. So if we have a sum that is less than another sum and the other sum converges, the greater sum converges, that means the smaller sum has to converge as well. I think that's a very, very important idea in this. So if you need to pause the video or go back and listen to that one more time, I encourage you to do so. Okay, now let's talk about why we know what v sub n is. Well, we can rewrite v sub n as just 1/4 all to the power of n, right? Because if we multiply this out, we just get 1 to the n over 4 to the n, and 1 to the n is just always 1. So v sub n we can rewrite as 1/4 all to the power of n. Now this might be familiar to you, and it should be familiar to you, as just the infinite or just a regular geometric sum with a ratio of 1/4. So the ratio is 1/4. And we know that we can use a geometric sum formula that we have to find this infinite sum. And that formula is the summation, so the infinite summation of v and n is equal to the first term, ace of 0, which in this case will start at n equals 1, over 1 minus the rate. Over 1 minus the rate. And in this case, ace of 0 is just when n is equal to 1, so that's 1/4. The rate is 1/4, so we have 1/4 over 1 minus 1/4. And so we can easily find this value, right? So we get 1/4 over 1 minus 1/4, that's 3/4, so 3/4. So this is equal to 1/4 times, remember when you divide fractions, you can multiply the reciprocal, so it's 1/4 times 4 over 3. The 4's go away, we're left with 1/3. So the infinite summation of 1 over 4 to the n is 1/3. And then what that means is if we keep adding, right, so this is equal to, if we keep adding 1/4 plus 1/16 would be the next term, right, plus 1, let's see, 4 to the third is 64, so 1 over 64 plus dot dot dot, we end up with 1/3. So we know that the infinite summation of v sub n is 1/3. And again, we know that the infinite summation of a sub n is less than that, so it's less than 1/3. And due to this right here, due to this comparison, the infinite summation of a sub n converges. And that is determining whether something converges or diverges with comparison.